Here we have a SAT math problem. Okay, let's go with the question. P of t equals to 350 times 1.44 to the power of 8a over n times t. The function p models the population in thousands of a certain city t years after 2010. According to the model, the population is predicted to increase by 20% every n months. What is the value of a? Okay, here we have an exponential function. So there are two types of exponential functions. One is exponential growth and the other one is exponential decay. So the one we have in our problem is exponential growth, because here this P of t represents the population, and it's predicted to increase by 20% every n months. Since it's predicted to increase, we have to consider the given exponential function as exponential growth function. Before we start solving this problem, let me consider an exponential function, that is f of x equals to a times 1 positive or negative r raised to the power of n. Okay, here we have an exponential function. It may be exponential growth or decay. So here the sign between 1 and r will decide whether it's an exponential growth or decay. If I have positive sign between 1 and r, it's this function represents the exponential growth. If I have negative sign between 1 and r, it represents the exponential decay. Okay, now let me consider exponential growth. Then we'll have positive sign between 1 and r raised to the power of n. Okay, here this capital A represents the initial quantity, and this n represents the time. It may be in years or weeks or months. It depends on the situation we discuss. And this r is the growth rate. For example, a quantity is growing 10% every year. That is, the n represents number of years, for example. So if quantity is growing 10% every year, means like we have to convert this 10% to decimal form. So that is 0.1. So to convert this percentage to decimal, we know that this 10% should be written as 10 over 100. Then we get 0.1. So this is the value of r. We have to plug in 0.1 for r over here. Then the given function will become f of x equals to a times 1 positive 0.1 to the power of n. So if you want to get the quantity after 1 year, you have to plug in n is equal to 1. So please remember, here in this situation, n represents the number of years. So if I want to get the quantity after 1 year, I have to plug in n is equal to 1. If I want to get the quantity after 2 years, I have to plug in n is equal to 2. So in this way, like we have to plug in the value for n to get the quantity after a particular period. So in the same scenario, in case the growth rate is different, for example, it is 20%, then it will be written as 20 over 100. Then when I convert this one to decimal form, it will be 0.2. So then the same function become f of x equals to a times 1 positive 0.2 to the power of n. In case if the growth rate is 30%, then the same function become 1.0.3 to the power of n. So here the value we have at the place of r will decide the growth rate. If I have 0.1, that is 10% growth rate. If I have 0.2, that is 20% growth rate. If I have 0.3, that is 30% growth rate. Okay, so now what we have done is we have to write this value 1.44 in the form of 1 positive r, so that we can know the growth rate. Already the growth rate is given, that is 20% every n months. Okay, now let me erase the stuff and continue the problem. Okay, now let me consider this particular piece of information. That is, the population is predicted to increase by 20% every n months. That is, when n is equal to 1, then the population is predicted to increase by 20%. The decimal form of this one is 0.2. So that means we have to write this value 1.44 in the form of 1 plus 0.2. So that we'll be able to do the rest of the stuff, and we'll be able to get the value of the constant a over here. Now my aim is to write this value 1.44 in the form of 1 positive 0.2. Okay, let me continue over here. So let me take the given function p of t equals to 350 times 1.44 raised to the power of 8a divided by n times t. Then we get p of t equals to 350. So how can we write this 1.44 as 1 positive 0.2? So we know that 1.44 can be written as 1.2 the whole square. When you evaluate this power, that is 1.2 raised to the power of 2, it is equal to 1.44 to the power of 8a divided by n times t. Okay, now we can consider the power of a power rule in exponent. That is, we have base a and exponent m, and for the complete stuff we have again exponent n. Whenever we have two exponents like this, what we can do is we can multiply the two exponents, then we get a to the power of m times n. So the same thing we have over here. Here we have base 1.2, we have exponent 2, and for this complete stuff we have this one as exponent. Now what we can do is we can multiply this exponent and this exponent using the power of a power rule in exponent. Okay, let me continue. P of t equals to 350 times. Now what we can do is we can multiply the two exponents. So according to the power of a power rule in exponents, then we get 1.2 times to the power of 2 times 8a over n times t. Okay, in the given exponential growth function, there are two variables which represent time. One is n and other one is t. Actually, t is in years and n is in months. So in the exponential growth function, there should not be two variables which represent the time. So when we have two variables which represent the time, it will create confusion, because we have two variables and also both the variables do not represent the time in the same unit. One represents in years and other one represents in months. So what we have to do is we have to get rid of one of the variables. So we know that the variable t in years, which represents the time in the given exponential growth function. We have another variable n which represents the time, that is in months. Okay, now we have to write either t in terms of n, otherwise we have to write n in terms of t. So what do we have to do? So I am going to write this t in terms of n, because I need n in the given exponential growth function, because the growth rate is given for n months. So I need the variable n which represents the time in the given exponential function. So how do we have to get rid of this t? So for that, what I'm going to do is I'm going to convert this n months to years, because already we know that n is in months. So whenever I want to convert months to years, I have to divide by 12. So when I divide this n months by 12, it will become years. Okay, now we have this t and this n over 12. Both of them are in years, and we have both these variables in the same exponential growth function. So we can equate them, because both of them are in years. That is t equals to n over 12. Now in this exponential growth function, we can plug in this n over 12 for this t over here. When I do so, I'll be getting only one variable, that is n, which represents the time in months. Okay, let me do it. So p of t equals to 350 times 1.2 to the power of 2 times 8a over n times for t we can plug in n over 12. So this complete n over 12 represents years, but when you consider n alone, it is in months. Anyways, now we got the given exponential growth function in single variable which represents a time in months, that is n. Since we got the given function in terms of the variable n which represents the time in months, now we can replace this t by n. Okay, let me erase this t by n, because t is no more in our function. Okay, now let me continue over here. That is p of n equals to 350. And now we can write this 1.2 in the form of 1 positive r, so that we can see the growth rate separately. Then we get 1 positive 0.2. That is, I'm writing this 1.2 as 1 positive 0.2. So this 0.2 represents a growth rate. And also already we know that 0.2 is 20%. That exactly matches with the growth rate given in the question. And also we can do some simplification over here. That is 2 times 8a is 16a. 16a times n is 16a n over, and n times 12 is 12n. According to the question, the population is predicted to increase by 20% every n months. Actually, this P of n represents a population. It's predicted to increase by 20% every n months. Actually, this 350 represents the initial population. What if I plug in n equals to 1? When I plug in n is equal to 1, this initial population 350 will increase by 20%. Okay, now let me plug in n is equal to 1. Then I'm getting p of 1 equals to 350 times 1 positive 0.2 to the power of 16a times 1 divided by 12 times 1. Okay, here both 16 and 12 have the greatest common divisor 4. That is 4 goes into 16 4 times, and 4 goes into 12 3 times. Then I'm getting p of 1 equals to 350 times 1 positive 0.2. Then when I simplify this one, I'm getting 4a over 3. So that is when I plug in n is equal to 1, the initial population 350 must increase by 20% according to the instruction. Okay, here 0.2 is added to 1, that is the growth rate is 20%. If I want this 350 to increase by 20%, then the value of this 4a over 3 must be n. So that so we'll have p of 1 equals to 350 times 1 positive 0.2 to the power of 1. To the power of 1 means like this 350 is increased by 20% when n is equal to 1. So if I want to meet the condition given in the question, that is 20% every n months, so the exponent over here, that value of 4a over 3 must be 1, so that the initial population will increase by 20% for n is equal to 1. So now we got the idea that the value of 4a over 3 must be 1. Now let's solve for a in this equation. For that we have to get up this fraction 4 over 3. For that we have to multiply both sides by the reciprocal of this fraction, that is 3 over 4. Let me do it. So when I do so, this 3 will cancel, this 4 will cancel out. Then I'm getting a equals to 1 times 3 over 4 is 3 over 4. I got the value of the constant a, its value is 3/4, and we find 3/4 in answer choice C. The correct answer choice for this question is C.